Oh, CNT125, we're working on Chapter 12. We just got done talking network monitoring. Now we're moving into the section with SNMP, Simple Network Management Protocol. Your enterprise-wide network management systems are going to accomplish fault and performance management, maybe some different ways, but are all going to use a similar type of architecture. Usually going to be SNMP, Simple Network Management Protocol. The network management architecture for SNMP, the main parts are the network management station, the managed devices, the network management agent, and the management information base. Super quickly, the management station, that is the central point where all the information gets pulled to. The managed devices are the things like your routers and switches that you're gathering information from. The management agent is the software running on those switches and routers that you're pulling information from. And the management information is the database of information that you're compiling, that you're going to mine for, is this functioning or is this not functioning? All right, let's dig into each one of these a little bit further. The network management station. This is going to be a workstation or a server that you are using as the central point to collect all your data. Could be a server, could be a workstation, but it's going to have network management software installed. Think of this almost as like the dashboard of your car. There are sensors all over your car, tire pressure, how much fuel is in your tank, the speed of the wheels as they're moving, the oil pressure, the battery charging rate. All that information, all those sensors come to your dashboard to show on your dashboard things are functioning right, or lights start showing up saying, hey, this is not functioning right. The network management station is that. It's pulling information from all the devices and displaying that on some type of dashboard, letting you know this is functioning, or it's yellow or red, it's not functioning right, something is wrong. That's your network management station. Cisco has their own product called Cisco Works, and it's really not hard to figure out. These are icons for all the devices, and they're green, so they're functioning correctly. If they start changing colors, they're letting you know something is wrong. Here's another network management system or station, SolarWinds. SolarWinds has a product as well. As you see here, you can tell, green is okay, red or yellow, there's some error or something wrong. OpenNMS, this is a Linux-based network management station, and these are all the nodes on the network, and again, as they start lighting up and changing colors, they let you know there's faults in the network. Managed devices are really anything you want to manage, anything you want information from. These can be pretty much any node attached to the network. Could be routers and switches, servers, printers, access points, desktops, phones, cameras, anything I'd want to monitor and get information from. Sometimes the network monitoring is really on just the network itself, the routers, switches, cameras, those sorts of things. Sometimes it goes further because the clients are super important on the business of that facility or that company. So it really is, what do you want to manage? Each of these managed devices contains several objects, a database of information, whether interfaces are working or not, what's the processor utilization, etc. And each of those managed objects is assigned an OID, object identifier. So it's a number string that identifies, hey, this number string identifies this interface, this number string identifies this interface. And those identifiers get pulled into a database. And that database can be, you can request information from that database. I need the status of this object identifier. I need the status of this object identifier. So your managed devices are these things, your devices on the network, laptops, printers, switches, routers, phones, IP cameras, anything you want to manage on your network. As I start capturing SNMP traffic, here are the OIDs. Here's these management identifiers, these OID, object identifiers. There's identifying a particular aspect of that device, whether it be an interface or processor or etc., or processor usage or etc. The network management agent, that is the software running on that managed device, that is collecting the information that'll report it to the network management station. That is literally the software or the application that's running on that device that I turn on to say, hey, please start collecting data and please send it to this management station. In our configuration, it's stuff like this. We start saying, hey, I want to know this information. Please send it out this interface to this node, and that would be your management station. Please send it to that node. Please collect this information, and please send it out this interface to this node. And that'll turn that agent on. That'll turn that process on to be maintain that information and share that information. The management information base, that is your database of information that you're collecting. Each of these devices has a little database, and those devices are going to share that with the management station. The management station is going to collect all that in a bigger database and then mine that for, is this functioning correctly? Is this functioning correctly? So we have a small database on each of the devices that you're maintaining information, and that is going to share it with the management station. The management station is going to compile all that. Here is actually when you install OpenNMS, you actually install PostgreSQL. That's SQL Server for Linux. That's a database for the management station. It's compiling all that information. And here is, when it's up and running, the MIB compiler. It's compiling all that information into a database that can be mined. Is this device interface working? Is this device interface working? Is this device interface working? You can pull from there. So overall, excuse me, the agents are going to communicate information about those devices via one of several application layer protocols. Typically going to use SNMP, Simple Network Management Protocol. It is part of the TCP/IP protocol suite and typically runs over UDP ports 161 and 162. We'll see that as we start working with SNMP in our network. SNMP can be used to reconfigure managed devices. So I can actually, the management station can send information back to the device and have that device change something it's doing. So it can actually be a report information, and then the management station report back saying, please do this now. SNMP is used for more real-time network monitoring rather than retroactive, like, oh, this is what happened. SNMP is like, oh, this is happening, now let's do this. So it can actually respond to events as they're occurring. There are different versions of SNMP. SNMP version 1 is the original version. It's rarely used. SNMP version 2 is still the mainly widely used one. SNMP3 is the most secure, but it requires extensive configuration. So not everybody has adopted SNMP version 3. The SNMP protocol is the traffic that's moving back and forth between the management station and your devices. That is the actual protocol moving back and forth. Here is some Wiresharks, and we're going to do this in our lab that we do this week. We're going to capture some SNMP traffic. There's your SNMP protocol. There is your port 162. So you're seeing that it is using the 162. There is different types of information. There's get request, get response, get next. These are particular types of SNMP packets that you get for, hey, I need information. Here's a response back. Hey, I need the next row of data that you're collecting. And that's what you start seeing when you start looking closer at these SNMP packets. Get request. I need this information, please. SNMP walk can issue an equivalent of a sequence of get messages. Hey, walk through these rows of the database for me. I need these, 5 rows of information. An SNMP trap, this is the agent can be programmed to detect a certain abnormal condition and report that to the management station all on its own. So you can tell the device, hey, if this particular thing occurs, let me know immediately. Don't wait for me to ask, let me know immediately. Those become very valuable because if you have a situation like a port goes down, that device can report it to you immediately and let you know this condition is occurring. And that way, me as the admin, I have that information first, and I might be able to even respond to it and fix it before people in the network start noticing and phone calling me, depending on what that situation is, or already be working on it while they're calling me. So here's another SNMP packet. Here is a particular trap. This is a particular trap. We're going to look for that in our network. We're going to generate a fault and look for that trap message. So here's an SNMP protocol moving back and forth between the devices, and here is another device. Here's the get request and get response communicating with the device. But then here is an actual device in the network that's sending a trap. Hey, this particular condition occurred. You told me you wanted to know when this thing occurred. So here's a trap message going to it. The SNMP information can be viewed and analyzed in different formats, line graph, map, etc. I can see data trends over time, or I can see a map of, hey, these are functioning correctly, and it's not hard to figure out. These that are red, there's issues. Yeah, these are faults in the network. These are faults in the network, so it's showing failures. And those would be things I would dig into, find out what's going on. Why is it showing that that's red? Is that imperative or not? And I can even show a more geographical map too, especially if I'm managing links between sites of our company spread across, a region. NetFlow is a proprietary traffic monitoring protocol from Cisco. It tracks all IP traffic crossing interface. This collects and records flow throughout the network. So this can be used to analyze the traffic abnormalities. Look for optimal balance between what's going on and what should be going on and what's going on. So this can be something that be used in a Cisco network, if you will. And again, it's going to generate data that I can look at application use and users in the network and so forth.